Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. Problem 1790. Check if one string swap can make strings equal. So basically we are given two strings of equal length. So a string swap is an operation where you can choose two indices in a string, not necessarily different, and swap the characters at these indices. So we want to see if the two strings can be made equal, right? So here, if you look at this back and the cap, so this is true. For example 2, so for sure it should be false, right? And for the last one, it's also be true because they are identical, and we can. So for example, we can choose two indices. We can choose the same indices, right? So here, actually, this problem is rather straightforward and also very easy in logic and small in size, I would say. So here, the length is bounded above by 100. So now, I guess for the purpose of this video, it might be explain how to use a zip function. So the idea is to locate the indices where the string characters differ, right? So we can actually allow at most two indices where the characters differ. So let me implement that, and then later we can explain the zip function. First, we can get the diff indices. So we want to find the indices where the two strings correspond to different characters. So let's get this index for I, and character 1, character 2 in enumerate. So because we use enumerate function, we track the indices, and also we want the pair of characters in the same position in S1 and S2. So here we are using a zip function. So here we need to add a filter, that is if C1 does not equal to C2, right? So then we just need to consider the length of this diff indices. Let's introduce a variable. So though it's not necessary, but it's brings us some convenience, right? So first, if m is greater than 2 or m equals 1, right? In these cases, so we need to return false. By no means we can make the two strings the same by the current swap operation. Another case is m equals 0. It actually corresponds to the case in example 3. So in this case, we need to return true. So in other case, so it corresponds to m equals 2. So in this case, let's first get the two indices, that is diff indices, right? So here I'm using unpacking, right? And then we can switch these two. So we want to return S1i equals S2j, and S1j equals S2i. Yeah, that's the full code. Actually, let's do a run. Yeah, it passes the three test cases. Now let's look at the generic case. It passes the generic cases. So now let me explain the zip function. So basically, if you have two iterables, say two list, let's see, array. Here I'm using two arrays as an example. You can use two strings. For example, you have 1, 3, 2, and then array 2. So for example, you have 3, 1, 1. Then if you do zip array 1 and array 2, then what you are going to get, you get an iterable consisting of tuples of this. So it's 1, 3, and 3, 1, and 2, 1, right? So here there are several points I want to make. First, order is important. If you do zip array 2 and array 1, so you're going to have an iterable corresponds to 3, 1, 1, 3, and 1, 2, right? So that's one thing. Second, So the length of the resulted iterable equals to the minimum of length for the iterables. So here I'm using array 1 and length array 2. So this is the default behavior. This is the default behavior. So you can do some changes. Here, if you have say array 1 equals 1 3 2 and array 2 equals 1 3. So then if you do zip array 1 and array 2, so you are going to get an iterable of this format. So 1 1 and 3 3, because the shorter length is 2, right? And third, you can pass a more than 2 arrays or iterables, right? And a typical use case is like this. For example, I have 1 3 and 2 4 and 3 3 say 5 3 5. Then this is a two-dimensional array, and if you pass it, so it's called, let's pass like this, star. Let's call this one an array. So what you get actually, this corresponding to unpacking. So it's equivalent to, say, I pass this zip with 1 3 and 2 4 and 3 5. So the result will be something like this in iterable. So 1 2 3 and 3 4 5. So if you regard it as matrix, so originally you have 3 by 2 matrix, now you have 2 by 3 matrix. It's like a transpose. So typically we use this quite a lot when you do coding. For example, if you have array, right? So you have array, so I want to compute the row sum, just apply sum to each row. And then if I want to compute column sum, so that is 1 plus 2 plus 3. So you can do this, right? And then compute sum for each of the element. I guess that's basically about it for the use of the zip function. And the problem here itself is, I would say, rather straightforward. And you can use this coding, or you can even make it shorter, right? A solution with 1 line or 2. With that said, I guess that's about it for the current video. Thank you for watching.